percentiles are very similar to quartile. So a quartile describes the shape of a distribution by dividing into fourths. And we like that because that's a nice, good way to look at data. Another thing we do is we split our data into hundredths, which is where we get percentiles. So quartiles, we split into fourths. Percentiles, we split into hundredths. So for a number p between 1 and 99, the pth percentile separates the lower p% from the upper 100 minus p%. What that means is, like, if, say, an IQ of 75 is, say, the 30th percentile. I don't know if it is, but just say it is. That's close there. What that means would be that 25% of IQs, or sorry, not 25, 30, because we said 30th percentile, 30% of IQs should be under a score of 75. And then what's remaining is going to be 70%, 30% of IQ are over 75. So it gives us this range where we can kind of break things down into upper and lower. And we use this a lot when we're trying to talk about things like how children are growing, stuff like that. So if you've ever taken a child to the doctor, at some point they probably, would have said to you, like, your child is in the 60th percentile in height and maybe the 20th in weight or something like that. So they're kind of telling you, like, the position for that kid. So if your kid's in the 20th percentile in weight, they're very, very small. And only 25% of kids in that age range, or they're about their age, would have a weight less than them. And that they're smaller than 80% of other children. On the same scale thing, if you get your kid tested like IQ and they say your kid's IQ is in the 98th percentile, well, that means that 98% of the population of children should have an IQ less than your kid, and about 2% would have an IQ higher than your child. Could we also see this like ACT scores, SAT scores, the same thing, they give you percentiles. Computing percentiles is very much like computing quartiles. So to put in context, your first quartile is representing your 25th percentile. So P25 is how we'd write it. Your second quartile represents your 50th percentile because it's representing half of your data is going to be below that. It represents your P25, P50. And your third quartile represents your P75 because 75% of your data should be below that point. So very similar to that, like if we want to find this location, we just said 0.25 times n, because it's 25% of my data should be less than that. So when we're trying to find a value of a percentile, we're going to do a similar thing. So we're going to put P over 100 times n. So if I know I'm looking for P30, my 30th percentile, the location of that is going to be 30 over 100, or just 0.3 times n. So very similar to that, if you get a whole number, then your percentile is the average of that position and then the next position up. If it is not a whole number, then we are going to round. And we're going to round up to the next value. Like I said, very much just like what we were doing with the last problem. Trying to fit all that in there nicely, but I'm not going to be able to do it. So the following table represents the annual rainfall in inches in Los Angeles during the month of February again. So we are going to compute now the 60th percentile. So we're looking for P60. So that means the location of that is going to be 60 divided by 100. And then we said before that our sample size was 45. We're going to times 45. So 45 times 0.6 is going to be 27. Like I said, before when we were doing things like 25 or something like that, we were getting these decimal responses. So that means I need to find the 27th number and I need to find the 28th number. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21, 22, 23, 24, 25, 26, 27, 28, 29. Oops, I went too far. 16, 17, 18, 19, 20, 21, 22, 23, 24, 25, 26, 27, 28. So it would be 358 and 371. So if we average those out, so remember add together, divide by 2, make sure you do parentheses. That is going to give me a 3.645. So that tells me that my P60, my 60th percentile, is 3.645 inches because it's rain. So 60% of February's, or not 60%, yeah, 60% of February's have less than 300, or not, sorry, 3.645 inches of rain. And the other 40% are going to have more than that. So also going backwards, and you could use this for quartiles as well. The following is the procedure to compute the 25th percentile. Oh, sorry. This is going to compute a percentile given a data point. So this is another thing that's computed a little differently depending on when you look at it. So sometimes we are given a value from a data set and wish to compute the percentile corresponding to that value. So the following is a procedure to do that. So we'll arrange our data in increasing order, like we always should have been. Our day has all been in increasing order so far. We're going to let X be the data value whose percentile is to be computed. And what we're going to do, I believe this was supposed to be a times here, we're going to have 100 times. And we're going to take the number of values less than X and add 0.5 to it. Then take the number of values in the data. So sometimes we just do the values less than X, but yours does it a little differently. So we're trying to figure out percentile. So once we get that, we're going to times it by 100 and it's going to give me a percentile. So we're going to round our result to the nearest whole number. And this would be our percentile. So going back to this rainfall data again, we want to know what percentile does 1.9 correspond to. So if we look for it, we find it right here. We have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17 data points or less than it. So if you want to figure out what that percentile is, we're going to do 100 times 17, and then we're going to add a 0.5 to it. Then remember, we already said there's 45 data points here. We're going to divide by 45. So we're going to have 100 times 17.5 divided by 45, which is going to be 100 times approximately 0.3, we'll say 38 repeating. So if I times it by 100, I'm going to get about 38.9%. So usually like percentiles, usually use percent, you might say it's 39%. So we would say that P 39 is about approximately 1.9. So pay attention to your homework because they may actually round differently. I've been saying we usually don't use decimal percentiles. Okay. So we're going to compute both of these. So for your first example, sorry, the length of the Carolina wool spiders, first you're going to compute where your 88th percentile would be. So that's using this equation. So you need to figure out what that percentile is, divide by 100 times by n. And then this is the percentile length does 27 point x, 27 point x, 27.5 belong to. So in this case, you're looking for that percentile. So you're going to take anything, you're going to count how many numbers you have less than 27.5. And then you're going to add 0.5, and then you're going to divide by the total. And then once you do that, remember this whole thing is multiplied by 100 to turn it into a percent. Okay, so for the first one, we have my P, we're looking for the 80th percentile, so P is 88. We're dividing that by 100. And then N, oh, sorry, it's not 45, it's 40 here because it's the spiders, not the rain. So we're looking for 0.88 times 40. And I know 88%, an 88 percentile is a little weird. So 0.88 times 40, oops, is going to be 35.2. So if you remember, just like quartiles, if it's a decimal, we round up. So we go back and we look for 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21, 22, 23, 24, 25, 26, 27, 28, 29, 30, 31, 32, 33, 34, 35, 36. My 88th percentile is actually going to be 33.2. So 88% of Carolina wool spiders probably have a length below 33.2 millimeters. So what percentile does 27.5 belong to? So 27.5 is right here. And we have 10, 20, 30, 40, 50, 60, 70. Well, I don't know, I'm counting there. I'm getting tired, you can see. 10, 20, 21, 22, 23, 24, 25. 25 values are less than 27.5. We're going to take 25 and then we add 0.5 to it. And then we're going to divide by that total. So our total number of spiders is 40. And then we're going to multiply that by 100. 25.5 divided by 40, there we go. Times 100, this is going to give me 63.75%. So you could say 67.75 percentile is equal to 27.5. Or like I said, you might end up rounding that and saying it's my 64th percentile. Just because we don't use decimal percentiles very often or ever.